Good evening, friends. Now I am going to discuss about the Kirchoff laws. Kirchoff laws are used to describe about a electrical circuit. So these Kirchoff laws are two types. First one is Kirchoff junction law. So this Kirchoff junction law we are going to discuss now. Let us consider four branches like this. Let I1 be the current entering into the junction and I3 is the current entering into the junction. Let I2 is the current leaving the junction and I4 is the current leaving the junction. Then according to the Kirchoff first law, the algebraic sum of currents entering into the junction is equal to algebraic sum of currents leaving the junction. So here the algebraic sum of currents entering into the junction or the sum of the currents entering into the junction are I1 and I2. So just look at this arrow mark. This arrow mark is towards the junction. And here also the current I3 is moving towards the junction. So I1, I3 are the currents entering into the junction, and from this junction I4 and I2 are moving away from the junction. Therefore I2 and I4 are the currents leaving the junction. So according to the junction law, we can write it as I1 plus I3. These are the sum of currents entering into the junction. This must be equal to I2 plus I4. So this can be written as I1 minus or plus of minus I2 plus I3 plus minus of I4, that is equal to 0. So it looks like the algebraic sum of currents. Therefore this can be simply modified as sigma I is equal to 1 to 4 I is equal to 0. So from this expression we can say that the algebraic sum of currents is equal to 0. So this is about Kirchoff first law. And about Kirchoff second law, or this is also called as Kirchoff loop law. According to this law, let us consider a loop. Let us consider this is a resistor, and this resistor is connected to a battery of EMF E. Now current will flows from positive to negative. Let us consider the current as I. Then according to the Kirchoff loop law, the algebraic sum of change in potential drop across a closed circuit involving resistors and cells is equal to 0. So therefore the algebraic sum of change in potential, here this point you need to remember, change in potential. So the algebraic sum of change in potential drop across a closed circuit involving resistors and cell is equal to 0. Therefore from this circuit let us consider IR is the potential drop across the resistor minus the the EMF of the cell is E, this must be equal to 0. So this is can be written as or taken as change, that is delta potential is equal to 0. Here the important thing you need to understand is sign conventions. For example, we already know current always flows from high potential to low potential. So always the current has to flow from high potential to low potential. This current is called as conventional current. So the sign conventions for Kirchoff's second law can be taken like this. For example, let us consider this as a cell. This is the positive terminal, this is negative terminal. For example, if we move from negative terminal of the battery to positive terminal of the battery, this is taken as positive. Why? Because we moved from low potential to high potential. For example, let us consider one resistor. Let us consider one resistor. Take this point as A, take this point as B. Now let us consider current flowing from A to B, and we are moving opposite to the direction of current. Then it can be taken as positive, because current always flows from high potential to low potential. In this case, current flows from A to B, then A must be high potential, B must be low potential. Here one important point you have to remember, that is rise in potential is taken as positive, fall in potential is taken as negative. Here when current flows from A to B, there will be fall in potential, but we are moving from B to A. If you are moving from B to A, so we are moving from negative to positive. Therefore, if negative is low potential and positive is high potential, if you are moving from B to A, then we are moving in the direction of high potential. If you are moving in the direction of high potential, there will be rise in potential. That rise in potential is taken as positive. In the similar way, if we move from negative terminal of the battery to positive terminal of the battery, we are moving in the direction of rise in potential. Therefore, that rise in potential is taken as positive. In the similar way, if we are moving from positive terminal of the battery to negative terminal of the battery in this direction, let us consider in this situation we are moving from high potential to low potential. So if you are moving from high potential to low potential, there will be fall in the potential. The fall in the potential is taken as negative. Therefore, here the potential is negative. Now consider the situation of resistor. Now let us consider current is flowing from A to B, which means that A will be at high potential, B is at low potential, because current always travels from high potential to low potential. Then we are moving in this direction. Let us suppose we are moving in this direction, which means that we are moving from high potential to low potential, which means that there is fall in potential. That fall in potential is taken as negative. So simply we can understood one thing: if you are moving against to the direction of flow of current, that is taken as positive. If you are moving in the direction of current, that is taken as negative. If you move from negative terminal of battery to positive terminal of battery, it is taken as positive. If you move from positive terminal of the battery to negative terminal of the battery, it is taken as negative.